We'll be starting up here in about a little over a minute. You might want to go ahead and upload your or turn on your pods for the chat and the Q&A. We'll talk about them in a minute. One more minute to go. Like a NASA commenter here. We'll have our planned holds and all that fun stuff. Okay, about 30 more seconds. It's the top of the hour, so we'll give folks just a little bit more time to log in. So before we get started. Okay, here we go. So good morning, and welcome to the last of our series on roadway departures and the state's roadway departure safety action plan. My name is David Orr. I'm the director here with the New York State LTAP Center with the Cornell Local Roads program. Whatever name you like for us, we like. As long as you come and take advantage of our services and we see at Highway School and workshops and other events. Today we're going to be talking about the use of the ball bank to determine property advisory speeds for curves. And yes, we'll be doing some polls as we typically do when I'm doing the webinars. There's a handout, and we'll talk about how to get that in just a second. But you've been on these before, you know, really just open up the chat pod and it'll pop right in. And we're taking some materials from our workshop on safer roads, the roadway departure action plan from the state, and the proven countermeasures from FHWA. But this is a specific thing we've had a lot of folks ask about. Now, just as a reminder, if you're new to this, like our little squirrel friend here, your audio settings are down in the lower left. Open up the chat pod. That is where the handouts will show up. We've got not only handouts for today's workshop, but also some an Excel file you could use to develop your own curve study sheet if you don't really like ours. There's plenty of choices out there. And open up the Q&A. That's where I'm going to have you put your questions in. Any questions you've got, you can put in there. And I may ask you to raise your hand. Now, we're going to take a risk today. I'm not able to be in my office for a variety of reasons. So I'm running this and remotely. And that means videos that I play may be a little tricky. So like our video, our waterfall friend here, we'll see how they go. Hopefully they'll work fine. Okay. Now, this is worth one professional development hour here in New York State. Only the person registered. It is counted as a course, though that's not as critical as it used to be. If you're from outside New York, which we'll find out in a minute, you'll need to check with your state's LTAP center to see what the possibilities are. So again, let's do a bit of a welcome. And again, open up your chat pod and the handouts and Excel file and all the things we talked about will pop in. So let's see where you're from. Okay, who do you work for? Oh, I didn't clear them. Let me clear the responses. Clear. Okay, here we go. Where are you? What's your job? Who you with? Are you with a town, a county, city, village, state or feds, tribal, NPO, consulting, contractor, or who do you work for the weekend? That's what we got here. Oh, we got quite a few working for the weekend today. This is higher than normal. Oh, maybe all the rain. I don't know. Okay, got a good variety of folks. Okay, that helps me quite a bit. Thank you. And then I got to clear this one too. I apologize. I thought I'd cleared them yesterday when I was practicing. What is your job? Are you an administrator, an engineer, a highway superintendent, DPW commissioner, a planner, field crew, supervisor? You do whatever the boss tells you to do. None of the above. Yeah, that's expected, mostly engineers. If you put in none of the above, you got to put in the Q&A what you actually do. Okay. Okay. And then we'll clear the responses and see where you're from. you can click on the map. And again, if you can't access the polls for some reason, you can put them into the Q&A. We have some folks from Connecticut. Yeah. Somebody from New Jersey and our friend out in Lake Ontario. Okay. By the way, if you ever click on it, it's in the wrong spot, you can click on it again, it'll disappear. Just click on a different spot. Oh, we have somebody in Lake Erie this time. Okay. Okay. And we have a Malone person who put it in the Q&A because they didn't click on it. That's fine. Cool. Okay. That helps me quite a bit, more than you think, more than you know. Okay. So again, this is the last of our series based on the New York State's Roadway Departure Safety Action Plan. If you do download that, make sure you download the appendices. And a lot of what we've been talking about over the last few weeks or last fall is the roadway departure concept of keeping the vehicle on the road, reducing the potential for a crash, and minimizing the severity of that crash. Now, today what we're really going to be focused on is the idea of keeping the vehicle on the road, keeping them in their lane, between the lines, in the curve, things like that. And of course, I don't want to forget about the fact there is a call for funds, $90 million. If you have any questions on that call for funds, obviously we can help you out, but you can also send an email to Andrew Sattinger with the New York State Department of Transportation. And again, go to the local call web page, which has lots of good information. In fact, we'll even be highlighting a few things that are on that website today. So if you want some funds, it's for local roads, it's $90 million, and $10 million is set aside for developing local road safety plans, which we've been talking about, and it's due on June 13th. So you got a little over a month. Now, as we were developing all of these webinars, I got a lot of questions asked about curb signage. What's allowed, what's not allowed, all this kind of stuff. And one of the proven countermeasures from the Federal Highway Administration and the state's roadway departure safety action plan is compliant curve warning signs and pavement markings. That's compliant with the MUTCD. Not only is this a focus area for the state, but we know that it has a tremendous potential for reducing all kinds of crashes, head-on crashes, rollover crashes, fixed object crashes. They're good at night. Obviously, they're focused on curves, but it's certainly something we want to make sure we understand and do properly. Now, what do I mean by MUTCD? Well, a lot of you might have an old MUT sitting in your office. Realize the MUTCD has been updated, but it stands for the Manual on Uniform Traffic Control Devices. And to me, the most important word in this set is uniform, consistency. And we'll go through that over the course of our hour today. Now, the old one, prior to last December, January, depending on how you set your timing up, looked like this. They updated the National MUTCD. There's an 11th edition. It has a December date on the cover, but it actually was officially promulgated in January. And there is still the old New York State supplement. New York State is working on an update, and I will actually mention a few things I know they're going to be modifying in the new national as we go through our webinar today. But this is the current MUTCD, and as changes occur, we'll let folks know, and we are updating our traffic sign handbook to go with this. But the key is for curves is we want signage to help people navigate the curves safely. So is there a problem here? Yeah, pretty easy. Everybody can tell there's about 5 or 6 things wrong here, not the least of which is, whoop, thing went forward on me. Not the least of which is, obviously we don't want to be putting a regulatory sign on the same post with a warning sign. The curve's pointing in the wrong direction. It might help to have some chevrons and delineators up through here. Might help to have some edge line markings, things like that. But there's all kinds of things we know could be improved here. But let me just ask you this. What is the purpose of a curve sign with a plaque? Okay? What's the purpose of a curve sign with a plaque? Is it legal speed limits, somebody says? Is it a recommended speed, a suggested safe speed? Safety? Let's see what other things. I'll give you a few seconds. We're going to come back to this one, by the way. But I want to see what you start with. Warning. A warning to slow down. An advisory speed. A recommended speed. It's always fun to get different answers. Okay. So think about this as we go through and develop our curve speeds using the ball bank. Okay. We'll come back to this one. Now, what do traffic control devices, i.e. signs, signals, and markings communicate? Well, they communicate regulations, they communicate warnings, they communicate information. Good signs do it well. Poor signs also can communicate things like, well, we're too lazy to move that stick. We can't go slow on our own roadway, and we have no idea where we're going. Okay. Now, for curves, what we're really trying to communicate is something about the curve itself. Okay. So if you're driving down the road and you see a sign that says there's a curve to the left with 35-mile-an-hour advisory speed underneath, your brain has an idea of what you're looking at, sort of a hint of what that curve is going to do. Okay. Now, the AASHTO, American Association of State Highway and Transportation Officials design model, has certain criterion for designing curves, and they're actually related to the signs. We'll come back to that in a minute. There's some assumptions that are made. Let's see if they're true. We assume passenger cars. We design the curve around passenger cars. We assume it goes around the curve as a point mass. In other words, it's just the center of gravity going around the curve. It's not on four wheels. It operates at the design speed. We'll see if that's true or not. And the curve, the person driving the curve starts at slightly ahead of or at the point of curvature, where the curve actually starts. And that's where we get spiral curves in some cases. Are these things true? Well, oh, by the way, curves should also avoid loss of control due to skidding. We shouldn't skid. Yeah, okay, that makes sense. Here's the observations based upon both watching vehicles over decades and, of course, some research that's been done. Part of the problem, of course, is we are designing around cars, but what about trucks? What about buses? How do we put up a single sign that tells the trucks and buses what to do? Even if we're just looking at cars, there's two axles, and the center of gravity is important, but it's related to those axles as well. Think about if you get a vehicle with a front wheel drive versus rear wheel drive, those things change how the vehicle goes through the curve. We know most people go a little bit faster than design speed, especially on a dry day with warm weather, as opposed to rain like we've been having for the last few days. Oh, and by the way, people don't drive a constant speed through a curve. That's just not the way people actually drive. They drive with a particular speed. In fact, most drivers tend to overshoot the curve slightly. Okay? I'll explain that one here with a sketch in just a second. And there is actually some evidence on certain sharp corners that trucks can actually overturn before they skid. Okay? That there's plenty of friction available, so they don't actually skid, so they actually overturn before they actually start the skid. So, how does this relate to signs? Well, let me talk about overshoot real quick. So here's the idea. If we draw a line that goes to the center of the lane, center of the vehicle, the theory is it goes around the corner and it starts curving right at the point of curvature and comes out of the curve, and we're in great shape. Perfect, right? That's the assumption. But the evidence is that most vehicles actually tend to curve a little bit beforehand, and they tend to turn a little bit late. Okay? And once you know a road, you're probably not going to be too bad, but especially people who don't know a curve, they tend to turn a little bit too late. And what that means is there's a place right about here where the radius is tighter than the radius of the curve itself. So it's actually a little sharper than we expect it to be. And yet what we're doing is putting up a single sign that tells somebody everything they need to know about a curve. Now, again, we can enhance this with lines, we can enhance it with chevrons and delineators, but the key is we're trying to put up a single sign to give them a message. And one of the things that, if you really look into it detail, we're actually looking at driver comfort, not safety with cars. The speeds that we design for are designed around the comfort, what feels good to the driver, okay? We're making an assumption in terms of skidding and in terms of stopping based upon wet conditions. Not soaked, not rain like we've been getting, but, a pavement surface that's wet, not saturated. I mean, not saturated, not ponded or something like, but wet conditions, surface saturated, it's sometimes called. So what we're really giving people with our sign is information about the sharpness, and I put that in quotes on purpose, around the corner. So your brain has a sense when you see 35 with a curve to the left of what that curve feels like. Okay? That's what we're trying to give out as a message. And we'd like to have that consistent for all curves. So ask yourself, when do you need a curve sign? When do you need a supplemental plaque? Okay? Now, there's both requirements and there's also just thinking about dealing with the public. But let's go through the requirements and we'll think about the public in just a second. So in the new National MUTCD, okay, so this is the 2025 MUTCD, the 11th edition. If we look at the roadway type, there are requirements in there, okay? So I'm going to put some dots in. For freeways, any curve, okay, that there's a requirement to change the alignment of more than a given amount, you shall put up signs. So you have to have signs up to mark every curve on a freeway. That makes sense. Arterials and collectors without markings, they only made it a requirement for high volume, above 4,000, okay, or above, above 3,000. So 3,000 to 4,000 and above 4,000, you have to have them. And it's a should. You got to document why you couldn't do it if it's below that, in that range between 1,000 and 3,000. Now, if you have markings, you can get away with not putting the mark signs up as much. And for local roads, they continue to leave it as you may do it. Okay. Now, this is the requirements as are in the National MUTCD. I told you New York State is doing a new supplement. As part of the new supplement, we don't worry about markings in New York State. We have too much snow, we have too much ice, and the vehicle and traffic law actually specifically mentions that signs are the controlling traffic control device. So in New York State, as we move forward, freeways all have to be marked. Local roads, you may do it. That's up to you. Okay. I still think it's a good idea, but you may do it. But for arterials and collectors, you have to put up your signs if it's essentially above 3,000 vehicles a day. So if you're in the 1 to 3,000, you can document why. But they're really pretty cheap. So I'd still think they're probably a pretty good idea. But this is the requirements. So if you've got roads that are not marked that are arterials and collectors, by the way, there's $90 million sitting there to get them upgraded. Now, if you're not sure if you've got a road that's a federal classified road, New York State's functional classification viewer can be used. And you pull that up and you can see all the roads that are marked in this map that are red and green and blue would be roads that count as arterials and collectors. So you can see this is near Buffalo, okay? All the roads that would be marked in this case. And if you're wondering about the traffic volume, there's lots of tricks out there. One of the first places I would look, if New York State has a traffic data viewer. You can actually go in, and if they've done a traffic count, guess what? You can figure out what the traffic is. Now, if you do that, make sure you look at the actual data. And remember that traffic volumes can change. So I purposely picked a spot. This is in the town of Clarence. It's actually a county road. And I'm going to change colors because you can't see the white. Let's pick navy blue today. I picked a roadway where the traffic volume used to be 4,000. I got to go back to white. That's what I remember doing yesterday. So it used to be 4,000 vehicles, about 4,163 if you want to be precise, though 4,000 is plus 4,000 is fine. That was in 2021. By the time they did their last count in 2023, the number had dropped to 3,800. Now, the requirement is you're supposed to have the sign up, right? But even if you drop below the threshold, I'd still put that sign up. I'd call that a shall, because traffic volumes are going to go up and down. If anything, it's going to grow over time. This is the low end. If you're getting close to the boundary point of deciding whether you're putting a sign up, go ahead, put up the sign. Again, cheap insurance. Now, whether you decide whether it's a should, a shall, or a may situation for your sign, once you decide to put them up, then there's the decision of do you need a plaque? Okay? Now, in the National MUTCD, if the speed differential between the speed limit and your advisory speed is 5 miles an hour or and more, you can get away with just having markings in advanced signage. 10 or more, you got to have advanced signage. 15 or more, you have to add delineators. 20 or more, you got to have chevrons as well. New York State, again, is changing things in the supplement. Again, markings, we're not going to do that. So again, if you have any kind of speed differential, you at least have to have the advanced sign. Okay? That includes any plaque that you've got underneath. Okay? You can do delineators up to 20 miles an hour. The New York State DOT themselves are going to always use chevrons. That's their plan over time. They're going to bring everything up to chevrons, but you could still continue to use delineators, at least at the moment. That's the current plan. So the question is, which sign do you put up? Okay. Now, the requirement is that you have to have at least a curb sign. That's a shall. Once you put up a curb sign, you have to have at least a curb sign, though the advice is if it's 30 miles an hour or less, you put up what's known as a turn sign. Okay. So in fact, I'll even write that down. Some people call these turn signs and they call these curb signs, or corner, you might see. I've seen both. Okay. In the old MUTCD, there was no give or take. It was one or the other. You literally picked one or the other. If your advisory speed was 30 or less, you had to do the turn sign. The new one says you start with the assumption that it's a curb sign, and then you decide for 30 or less, what does it feel like, and you document why you put one sign up or the other. Okay? Because it's a should condition for 30 miles an hour or less. If you have two curves that are separated by less than 600 feet, you would put up a double curve or a double turn. And of course, if you got three or more, you would actually put a winding road sign up, though it is advised if one of those curves within the winding road is much sharper, you go ahead and put a supplemental additional sign for that particular curve. Okay? And we have lots of roads like that in New York. It's a curvy state. So let me give you an example. I'm going to make you pick here in just a second. So I've got a roadway. I'm going down the roadway. You can see the speed limit down here is, put it where you can read it, 40 miles per hour. You can see it's a turn sign. I'll even blow it up a little bit. It's a curve sign, actually, to the left, and it says 15 miles an hour. And down here at the bottom, you can actually see it's a chevron, and the road, if you look at it from above, actually does turn almost 90 degrees. It's about 80 degrees if you look at that on a map. So let me ask you this. Based upon that, which sign would you choose? You can click on it. You can actually click on the picture. Which sign would you put up if it were your choice? You have to put up the one on the left. That's a shall. You should put up the turn sign, and you have to document why. At 30 miles an hour, I think really does come down to how that curve feels. At 25, boy, you better have some really good reasons to not put that up. Think about how it feels. Time you get all the way down to 15, really be hard to justify why you would only put a curve sign up. I really think you probably should be thinking about that being a turn sign. And again, once you're done, drive it, see how it feels. And we'll do an example of that over the course of our time. So how do we do advisory speeds? Well, there are tons of methods out there, okay? Where do you put the sign up? Depends upon advanced longitudinal placement and the deceleration from 85th percentile to the advisory speed. 85th percentile, what is that? Well, it's the prevailing speed, it's the operating speed, it's a reasonable speed. It really is all of those, okay? And the reason that we need to know about the 85th percentile speed has to do with, well, like it or not, it changes how much time people have to react. So let's look at reverse turn sign with a 35 mile an hour plaque underneath. 85th percentile speed's 45 miles an hour, and the speed limit's only 40. And by the way, that matches what most observations are. People tend to go a few miles over the speed limit at the 85th percentile. Okay? So if we come down here at 35 miles an hour for where we place our sign, if we use the speed limit, okay, we would be different than if we use the 45-mile-an-hour speed. In one case, the 45-mile-an-hour one, we'd be 255 feet for our advanced signs. For the 40-mile-an-hour, we'd only have to put it at 190 feet. Don't have as much reaction time. Again, you need to be consistent. So I'm going to ask you to raise your hands. If your agency uses 85th percentile, raise your hand if your agency uses 85th percentile for your advanced signage. Okay. So quite a few of you. Okay. Now I'm going to lower everybody's hands. Raise your hands if you use speed limit every single time. Now, I will tell you, be consistent. Pick a consistent method, though there is a couple of caveats. One, if you know there's a tremendous difference between the speed limit and the 85th percentile, I really would look at the 85th percentile. Give people that reaction time. If, on the other hand, it's 5 miles an hour, again, be consistent. Remember, uniform traffic control devices. And just as a reminder on the 85th percentile, what we're doing there is essentially we do a speed count, whatever technique we use, we put everything into the thing, we get a cumulative count, and then we come along till there's 85th percentile. So if we do the cumulative percentage, we come down here till we find the 85th, and it's going to be in this range right here. So we'd probably call that 34 miles an hour. Okay. Versus the average speed, which would be in this ballpark right here, and that'd be about 28 miles an hour. Okay. So that's a 6 mile an hour difference. And just got to keep that in mind. So what are the methods that are allowed in the MUTCD? Well, there are 5 that are now allowed in the MUTCD. We're going to go through all 5 of them. I'm going to do them in a slightly different order than is the A, B, C, D, E listed in the MUTCD. I'm going to go through them with the design equation method, the safety-based method, the compass method, the accelerometer, and then finally we'll finish with the ball bank. In fact, we'll spend most of the last half hour talking about the ball bank. But I do want you to understand the other equations. We're going to use a particular curve that's right near the town of Ithaca's highway garage on 7 Mile Drive. It's just off to the right. We have a roadway that's got a 45-mile-an-hour speed limit. If you're coming from the north, because you can see north is to the left, there's a 30-mile-an-hour left curve, okay? And then going to the right, there's a 35-mile-an-hour right curve, okay? So let's go through and see if we like this signage, okay? So let's look at the 5 methods. The first method is known as the design equation method. It's really the AASHTO design equation. It's the one we use when you actually design a roadway. So it's reversing essentially, rather than picking a speed and then choosing the super elevation based on the radius or vice versa, you take the existing radius, the existing super elevation, and a side friction factor, and you calculate what the advisory speed is, okay? And the design side friction factor is a table right out of the AASHTO design guide, the geometric design guide, and yes, that's linked in the handout. So in this case, southbound, we went out there, we actually measured the radius. You can also use Google to do this, and you get about 300 feet. And you've got a super elevation that varies within the curve itself from only 1 to 5 degrees. It actually gets pretty flat at one point, okay? The side friction factor is based upon the design speed. We're going to use the speed limit as our starting point. So if we use the speed limit as the starting points, and I'm going to change the color so you can see it. So we have a design speed. Remember, it's 45 miles an hour. So we come over here at 45 miles an hour, and we get a value of about 0.15. We could go back in and check that with the 85th percentile speed if we wanted to. And if we did that, it would actually slightly lower, but we'll start with that just to get us a starting point. Again, your agency needs to be consistent. If you do that, the advisory speed values you're going to get are 26 to 30 miles an hour. Okay. Northbound, radius is smaller. Okay. It's about 290 feet. Yeah, it's actually probably 288. It's about 12-foot lanes there. It's actually steeper. This roadway doesn't have a consistent super elevation all the way around. It goes from 10 to 13%. It's actually pretty dang steep, much steeper than you would normally want, but it actually worked pretty well for them. Um, Friction factor is a little steeper than we want, is still going to be 0.15. The advisory speed then becomes 32 to 34 miles per hour. So southbound, we would go the worst case scenario of 26 and round down to 25. And northbound, it would be the worst case scenario of 32 miles an hour, and we'd round down to 30. So that would be your advisory speeds. Okay? That's the design equation method. There's another one, it's a new one. It's called the safety-based method, and it uses a chart. Okay? And what it is the crash factor is based upon those crash modification factors that we've seen in some of the previous webinars. And essentially, it's just taking the side friction demand and you calculate it based upon the advisory speed, super elevation, and the radius. That's all there is to it. Okay? And what you do is you assume a series of advisory speeds, and you find the case where you've got the lowest crash factor. Okay? And that's the one you're going to choose in terms of where you fit. So in the case of southbound, we have the same data. We go in, we plot those data points on this chart, and we find the point that has the lowest crash factor. That's the one that's darker purple. And it has a crash factor that's just above 0.5. And the advisory speed then becomes about 25 miles an hour. Because you'll notice it says advisory speed differential. Okay. And so you take the speed limit, you subtract 25, and you get your differential. Northbound, you would plot those points. You pick the lowest crash factor. That's now the green dot. That's a 15 mile an hour differential. And together you get, hey, you get similar numbers, 25 and 30 miles per hour. Same answers, time you round them down. There's a compass method which is available. This is based out of Texas. Texas uses this where you actually do compass headings at the 1/3 and 2/3 points within the curve. You do a change angle. You calculate super elevation with the ball bank or with the level. You get the length between those points, and then you use some software to calculate it out. It's using the design equation to some extent, and I don't have a link to it because I couldn't find a free copy on the web. I don't want you to have to pay for something. So if you'd like to, you can go look that up. There's reports on it, but essentially it's using very, very similar kinds of equations based upon compass points and curves. Let me ask you this. I just gave you 3 methods that are out there. The compass, the safety, and design equation methods. There's some concerns you might have if you use those design equation methods. What would be concerns? I'm going to let you give about 30 seconds to put in your answers on what's the concern with those. And then we're going to share the responses. Okay. Let's see what y'all came up with. How accurate is it? Well, obviously that's an issue. Okay. Though, you can get pretty accurate. Heck, you can use Google for a lot of this stuff. Say they don't incorporate the feel of the driver. Yeah, that's a concern. There's always unique situations. Ah, there you go. Super elevation changes. We could go back out and do this as a starting point. They're actually very good starting points. They get you in the ballpark. But you'll notice the super elevation changed through the curve. It's not consistent. Part of the assumptions with these equations is the curves are consistent. And if you're going over a crest, if the curve super elevation changes, there's some field conditions, as someone just said, that may differ. Imagine going around a corner, and instead of having a super elevation transition slowly over a couple of 100 feet, it immediately drops in 50 feet. What's going to happen to a vehicle? It's going to tend to be thrown a little bit. And so you'd have to measure a whole bunch of points and choose a worst case scenario, and it doesn't deal with the fact that as you're going around a corner, there might be bumps. Again, I like it as a starting point. I do worry a little bit about it not having as good from a field standpoint, but it is available. And so it's important. Now, someone mentions here friction coefficients change with the weather. They do, but then so does that sign. And we'll come back to that. It's a really important point that I'll bring back up later on when we talk about what the signs actually do. Okay. So you could use an accelerometer if you'd like. It's very similar to the ball bank. Okay. Now I'm going to ask you to raise your hand if you own an iPhone. Anyone have me own an iPhone? Raise your hand. Congratulations. You can get a ball bank indicator app. They'll go on your phone and you can mount a vehicle. Okay. Do not ask me why they've never made an Android version, but there is an iPhone version that will actually do a ball bank. It's not really a ball bank. It's using an accelerometer, the one built into your phone. Okay. It it's very similar to the ball bank. In fact, the ball bank is really just a mechanical accelerometer in a lot of ways. Um, New York State is actually using something called the Riker system. It's a trademarked, copyrighted system for its curves. Something they call the Curve Advisory Reporting Service. Okay. Um, it's a service you can purchase. The advantage of the system is it does allow you to drive it at whatever speed you can drive it. Though I will tell you, there's some really good evidence out there that says you really need to drive it 3 times to get consistent results. So that you're trying to give a uniform, consistent method. And it's something you could look into doing. Again, we're trying to have consistency, and that's what New York State is trying to do. Very, very similar to the ball bank. So let's talk about the ball bank a little bit. Okay. Now, I'll ask you, raise your hand one more time. How many of you have access to a slope meters, i.e. ball bank? And they make electronic versions, by the way. Okay. If you don't, you're definitely going to want to get one for a variety of reasons. And heck, you might have one in your grader and not realize it. Just can take it off the grader and put it in your car. Okay. So about a quarter of you have a ball bank. Okay. Now, when I was setting this webinar up, I searched for the word forms in all my pictures. And for reasons I don't know why, it gave me a caterpillar when I typed in forms. It also gave me a butterfly when I typed in forms. I don't know why, but I can tell you right now, you've probably heard me say this before. I love forms. I hate paperwork. So what we've done, and again, this is in the handout, we have some quick answers. We developed a new form as we were developing this webinar. Um, we have forms available, and they're linked in the handout materials, okay, that talks about how to do a ball bank. So there's forms available for single curves. There's forms available for multiple curves that exist out there, okay? You do not have to reinvent the wheel, okay? So there's 2 that we had done already. We did a new version of it. If you wanted to have a form, it's got places for names. Make sure you don't forget something. Again, I love forms. I hate paperwork. There's a spreadsheet version of this particular one. It's linked. You can update it, put your own information in there, modify it if you want. In fact, if you make a major change, you like it, send it back to us. We'll post it. Maybe we'll update ours. My goal is to have something that helps you not forget something when you're doing your ball bank study. So how do you do a ball bank study? Okay. And the link, if you open up your chat pod, okay, it will show up in the chat pod in about 20 seconds. We'll give you time to open up your chat pod real quick, and Mandy can directly answer your question too. So you mount the ball bank in a standard car, okay? Now, there's a reason it needs to be in a standard car, and that's, again, consistency. We don't want it too high up. It changes how the accelerations are going to occur. So we want it in a standard car, okay? You level the ball bank with 2 people in the car. Okay, that's actually pretty important. We'll ask you why in a minute, but think about that. You then take a series of readings, starting at a relatively slow speed. Now, I got a little asterisk there. If you're checking existing curves, you can drive it at the recommended speed, and we'll talk about how you do it with multiple curves to check things. Okay, you can also drive it at a reasonable speed for a first cut, so you don't start at 20 miles an hour when the speed's 40 and it takes you forever to get there. Because normally what we do is we record the maximum ball bank reading and then do additional runs, increasing the speed about 5 miles an hour each time until we cross over the threshold value. So again, we start at a relatively low speed, but again, a lot of times we like to drive the road just to give it a check before we get doing anything else. In fact, we did that in this particular case too. Now, why 2 people in the car for the ball bank? Why do you think we want 2 people in the car? See what you come up with for answers. There's about 3 or 4 things I'm hoping to see when I click on the little button here. Okay. Let's see what we get for responses. Okay. Did a little Wordle today. Balance, we want the car to be level. We want it level how it's going to be used. We want to start it with level. That can actually be one of the hard parts, is finding a level spot within your parking lot, or, most roads already have a super elevation to them, or a crown. Distribution of the weight in the vehicle. Okay. I'm looking for, reading and distracted. I start seeing that word show up. As you're driving the roadway, you really want one person who can concentrate on driving the road consistently, and you want them to try to drive where they turn as they come into the curve, just like the AASHTO model. Remember, we're providing a uniform message. We have another person who can concentrate on recording the ball bank information. That's why some people like the automated systems like Riker, or an automated electronic ball bank, because you can have one person drive. If you're only having one person drive, they got to make sure they record things. And again, you got to start it with it being level with who's ever in the vehicle. Okay, so keep that in mind. Okay, so you need to have one person record, one person drive most of the time. You want the car to be balanced and used how it's going to be in the field to get a starting point. Okay, and then that person driving can concentrate on their driving task and not worrying about the ball bank. Okay, and even then, you'll see it's not perfect system that's out there. Okay. Now, when you mount the ball bank in there, it does need to be level on a flat surface. Okay. If you just drive on any old surface, though, it may not be flat. And you can see in this case, we have a reading of about 2 to the left. Okay. The vehicle's tilted slightly. You can even see in the background the building there where it's tilted in the parking lot before we got started. Okay. Now, we had already leveled it in a flat spot. But the key is you want to level your ball bank. We were buying a fleet vehicle, so we just used some 3-inch strips. But if you're doing it for your own agency, you could do a more permanent mounting. When I worked in Yates County, we had a permanently mounted spot, and we'd take it off the grader and put it in the car so we could do ball bank readings. So what I want to do is I want to do a reading, and we're going to be brave here. We're going to do a video. We'll see how it plays. At initial run on this 7-mile drive at 30 miles an hour. Okay. So you can see we did a video, and yeah, it gets a little pixelated, so it may not be perfect to read, but as you come around at 30 miles an hour, and remember this one's 35 is the speed limit on the advisory plaque, you can see we get a reading of about 7, okay? And then we'll come back and we'll go the other southbound, okay? And we'll go southbound, and we'll also do 30 miles an hour. We'll see how this one goes. We already know that it's got a sharper advisory plaque, so we'll see how this one does. You pixelate a little bit on us. And we might post these later on. In this case, the ball bank reading, and it's the middle of the ball, remember, was about 11. Okay? Is that good or bad? Well, let's go back and look at the advisory devices. The recommended ball bank readings. If you're driving at 20 miles an hour or less, say in an urban area, you can go up to 16. You still got plenty of friction in the tires. 25 to 30 miles an hour, you can go all the way up to 14. Most of our roads we're going to be driving are going to be higher speed. So in that particular case, we're going to have a limit of 12. Okay. We didn't do it, but some people do. They'll come in here and they'll actually take and they'll mark. I can't quite see that. Let's pick a different color. We'll do yellow this time. They'll actually come in here and they'll put a marker. You can actually see a yellow line or a different colored line to make it easier to see at the 12. Okay. They've got little marks, but can be done. You could video it. You can take pictures. The key is to get a consistent reading more than anything else. Okay. Now in this case, we had a 7 and 11. So we're fine. No problem. So let's do a second run northbound, 35 miles an hour. Okay. Now, ball bank reading of 11. We had 7 before, so let's just see what that does. Again, it was pixelating, but let's see if you can see the 11. Watch carefully. Come around the corner. Try to behave consistently. It gets a little pixelated. Yeah, of course, right at the worst possible time. But yeah, there's a ball bank reading of 11. Okay, still good. Okay, let's try going southbound. Okay, we'll see if we can do this. See how pixelated it gets. Okay, I'm going to back it up a little bit. Try this a little bit one more time. What reading do you see there? Put in the Q&A what reading you can see there. Somebody put in the Q&A what the reading is. 15, 14, 14, 15, 14 to 15. Again, you'll get pretty good at it after a while. Okay. And again, consistency matters. When we did it, we checked ourselves. It actually does get up to 15, though when I stopped it, it was at about 14. So yeah, if you had said 14 here, it actually gets up to 15 if you watch the video carefully. Okay. So we have a value of 15. So we actually know that one's too high. Okay. So let's go and look at our recommended readings, remember. So in this particular case, we have our ball bank study, southbound. We did a reading of 11 and 15. Okay. And we know that we can go up at 35 miles an hour to 12. Okay. At 30 miles an hour, we could have gone to 14. So in this case, for the southbound reading, this one's too high. And for the northbound readings, this one's too high. And what you do is you keep going till it's too high. And so guess what? We're going to have 30 and 35 miles an hour. Cool. Now, when you are done, you do need to do a check run. You should probably do a double check run if you've got time. So it means a total of 3 runs to check everything. Not a bad idea. It's actually recommended just like it is for Riker. But the cool thing about it is you could do multiple curves at one time. You don't have to go crazy. But now you've seen a bunch of these videos. Yes, a little pixelated. You can see a picture of the curve. Okay, it's down there. Which I'm going to clear the responses for the southbound curve. Okay, that's the one, by the way, that's 30 miles an hour. Okay, and I'll go back up here. 30 miles an hour. You can see the curve. You've seen the video. Which would you choose? In this case, we'll make it simple. I'll even draw them for you. Let me go my pen here. Ink color, if it'll show. Some days it does, some days it doesn't. Nope, it's not going to show. It's going to be a left curve or left turn. Which of those are you going to choose? So you can click on this. Which one would you choose? The left turn or the left curve? A lot of you were choosing the sharper turn sign. Some of you were driving the sharper curve sign. Again, this is where I actually like the change in the new MUTCD. In the old MUTCD, it would have been a shall. You shall put up the 30 mile an hour turn sign, the one that's on the left. Okay? In the new MUTCD, you have to document why you put up just a curve sign if you wanted to put up the flatter curve type sign. Because how does it feel to the driver? You want to be consistent to them. Does it feel more like you're just a sharp curve, or does it feel more like it's a turning of the vehicle? Because we're trying to give a message consistently. And this is what's there. Okay? Again, if you can't put a poll, you can always put your answer in the Q&A. You can always take an answer in the Q&A. So they did a curve sign. Okay. I actually think that's okay. It drives like a curve. It doesn't drive like a turn. I've seen roads that had a higher speed than 30 that actually felt like a turn. Okay. But normally you don't see a turn in every single case at 30 miles an hour. Certainly by the time you get down to the 15, absolutely, it feels like a turning of the vehicle. But how much deflection is it? How much angle is there? These are all factors that can come into play. So whenever I'm looking at it, I'm going to ask myself the question, which does it feel like? But you need to document, document, document if you're doing anything other than the ones that are in the chart. Okay? So there's some common issues that we need to worry about. The three most common issues when you're doing a ball bank, and a lot of reasons people think ball banks aren't as good. One of them is we're not consistent with our speed. Okay, and as I'll show you with a video with multiple curves in a minute, it's hard sometimes, especially roads that go up and down a lot. It can be very difficult to do. Okay, consistency matters, especially with a ball bank. You've got to drive the road so you're coming close to the model because you're giving a message back. So don't cut that corner too soon. And don't overshoot and then jerk the wheel. You got to drive the road smoothly, which is why it's sometimes good to do a check run before you get started. So let me illustrate this to you. We're going to do a southbound drive. I'm not doing an inconsistent speed. I'll show you that with the multi-curve one, but let's cut the corner at 35 miles an hour. Let me get back to where I can actually do that. I'm going to cut the corner going southbound, okay? And I'm going to essentially drive right along that yellow line and go nice and smooth. And I apologize for the pixelation again. Maybe we'll post these up online so you can go see what they look like. But when I did that, I got the ball bank reading instead of 15, I got all the way down to 11. Okay? I was actually able to make it look like that curve was flatter than it really was by driving, just cutting into the yellow slightly. Now, a lot of people do drive that way, but remember, the sign is to give a message to people. So you can cheat a little bit. Don't do that when you're doing a ball bank. Drive consistently coming around the corner. Okay? Now watch what happens, let's see if it shows up better this time. We'll give it one more chance. Nah, it's a little too pixelated. So yeah, we'll post these videos the same place we post a copy of the webinar. It'll take us a couple of days to get that done, but we'll get that posted. Now, the other possibility, and this is the one I think is even more common, and again, we already talked about the fact that people tend to do this. I'm going to have to restart PowerPoint. I was afraid of this. I apologize. Give me about 20 seconds. It's going to take it to restart. It's good old PowerPoint being PowerPoint. Um, I had to do this yesterday. I'm using my laptop. As I mentioned, I was taking a risk. You can look at the form while it restarts. And remember, if you have any questions, you can always throw them into the Q&A. Great question that's up there. How does the vehicle impact the results in your experience? It actually makes a huge difference, and that's exactly why you are supposed to use a standard sedan. A Ford Taurus or an SUV should not be used. You need to use a car so that we're consistent, okay? We used fleet vehicles, which are sedans, Prius, to be honest, and you should be consistent if you can possibly be consistent, okay? So yes, it does make a difference. You can see a factor of 3 or 4 difference in the ball bank reading. So yeah, you do definitely want to use a sedan, okay? So now let's go through and we're going to cut the corner. I'm going to do it late. And again, we'll post these videos later on, okay? So that's cutting the corner. But now watch what happens when I jerk, okay? Remember, I had 15 before, so we'll take the risk here. I'm going to jerk the wheel. I'm going to over jerk it a little bit, like a lot of people tend to do. And yeah, we'll have to post that later on. I got a ball bank reading of 17. Okay. By the way, you could actually get this probably up towards 20 if you really jerked it hard, but I was trying to drive it the way a lot of people do actually drive curves. You're going to get an inconsistent reading. Try not to do that. Okay. And now the person puts in the Q&A, even though the majority of vehicles on the road are smaller SUVs, crossovers. Yeah, that's right. That's right, exactly. We are not using SUVs and crossovers, even though they're a majority of the vehicles. And we'll come back to that in just a minute. It's a really important question, why we use this consistent vehicle. Let's go back to our purpose of our sign, okay? Think about it now. What is the purpose? I'm actually going to clear the responses and let you put new ones in. What is the purpose of a curved sign with a plaque? Yeah, it's a warning. Very good. It's a warning device, okay? You're trying to give people communication of what the curve drives like. Is it a sharp curve? Is it a relatively flat curve? Is there a major difference in the speed? If it's really a major difference, we're probably putting up chevrons and delineators. While you're answering that question, okay? Is using a sedan a requirement? Yes, actually it is. You should use it. The should, but you should use a sedan, okay? Going to ask you to raise your hand while you're answering this question. Weather today is rainy. Do you slow down when it's a rainy day? Yeah, you slow down on a rainy day. And yes, by the way, somebody mentioned you use cruise control when they're doing the ball bank. I use cruise control all the time. Absolutely. Okay. It's a information. How about an icy day? You slow down on an icy day? Yeah, of course you do. How about on a hot day? Yeah, you can actually go faster. If you own a low vehicle like a Mini Cooper, you could go faster around the corner. If you're driving a truck, you've got to go slower. What we're putting up is a single sign that gives messages to buses, trucks, cars, SUVs, heck, theoretically even bicyclists to get around the curve. I like this answer. Informational field of curve. Remember, is the MUTCD, the Manual on Uniform Traffic Control Devices. We're giving a consistent message. Now, if you've got multiple curves, you can do the same trick. Get your form out, fill everything out. In this case, there's two curves we care about going to the west, okay? And a 35 mile an hour left and a 20 mile an hour double curve, okay? And again, I doubt it's going to play, but I'll be a risk. I'll take a risk. We're getting close to the end of the webinar. We'll take a bit of a risk. Would a CRV be acceptable? Is that too much for crossover? Boy, I don't know. I really don't know if a CRV would count. I own a Subaru Crosstrek. It's fairly low. The key is to be consistent. You want to document things. Okay. So it's something to think about. But as you can see, as I'm driving this particular roadway, as we come to the sharp corner, I'm going down a steep hill. This is near Buttermilk State Park in Ithaca. And it's really hard, even with cruise control. The cruise control just couldn't maintain the speed. And we started going too fast. Okay. And as we started going too fast, and I had to try to slow down. And then as I slowed down, I got going too slow. It can be difficult to control the speed. We know that as you're doing multiple curves. But you can do multiple curves if you got two people in good forms. In this particular case, it said 20 miles an hour, but I was going 25 and that didn't even come close. So it's really more of a message of feel in some cases. Okay. So you really want to look at your signs carefully. Um, you can always be conservative in terms of your turn and curve sign choices. Okay. So keep this in mind. We're trying to give information to the driver. So keep that in mind. You're always going to put up a curve sign, and then you have to decide, do I put up the turn or hard left, right, as somebody put into the Q&A. Okay. So it's a shall put up a curve sign once you put them up. Okay. Now, one of those curves had an intersection in it. And we're going to end with this last little question for you. It's curve with an intersection. Okay. You can see there's a curve sign. It says 40 miles an hour curve to the left. And they also have an intersection sign. Okay. So again, I'm going to clear these results because this is from the last time we did this. Which of these three would you choose? If you have an intersection in the middle of a curve, which of those three would you choose? Okay. Most of you are choosing the one in the middle. Technically, according to the MUTCD, the answer is the one on the right. Because the one on the right is the main road going straight and the minor road going off to the right. And yet it would confuse the driver. One of my favorite signs in the MUTCD, if you've got intersections and curves combined, is something called the W1-10, where you would actually put in a small black line in the curve sign to give people the information. Okay? Exactly, curve sign with a side road variant. So rather than having a Y intersection, which is, by the way, what used to be there, how about putting up this? That's confusing to people. How about that? That's technically correct, but still confusing. I prefer one sign in this case, 40 mile an hour, curve to the left, straight, gives them everything they need to know, and a few chevrons and some stop aheads. Okay? Better signage, communicating consistency to the public. Last little reminder, this is all part of this roadway departure call for projects. If you have questions, send them to the state and look for putting in your plans, your $90 million. They're due on June 13th. These are federal funds, so you want to keep that in mind. And so if you have not done a federal aid project lately, or you've got any questions, we are doing a 4-hour session on local federal aid, an overview on May 22nd, okay, from 9:30 to 2:45. And with that, if there's any questions, please throw them in the Q&A real quick. We'll answer any last questions you've got. We will post these videos from the ball bank. It'll take us a couple of days. Neither Nick or I, who sort of organize these videos, are in the office today, but we will get them up there within a few days. With that, I don't see any more questions, Amanda and Jody, so thank you all for helping out. Oh, people want to know, what is the app for the iPhone? You go on the iPhone and you actually, I don't remember if you type in ball bank or slope indicator, one of the two. I don't have an iPhone, so I can't remember the exact name, but I know I found it once. Pretty sure I searched for ball bank, but what I can't remember if it was one word or two. Good luck with everybody. Ball bank, somebody else found it. Ball bank, one word. Okay. Thanks, everybody. Have yourself a great day and stay dry. Bye-bye.